Welcome, my wonderful scholars. Still on JAM question 2001. Question number 6. The resultant of two forces acting on an object is maximum if the angle between them is. Okay. In physics, we have what we call vectors. A good example of vector is force. Okay. Most times, you see forces acting on a body, and the question becomes, what is the resultant force? For instance, here we have two vectors, A and B, at angle 90 degrees. Here we have two vectors, A and B, at angle 45 degrees. So the question targets to know, at what angle will these vectors or these forces give us the maximum resultant force? Where will the forces act together to give a greater effect? Where will the forces act together to give us a greater effect? The best way to maximize forces is to make them to have no angle between them. Let's see. Okay. If vector A and vector B act on this body, it can be anybody at all. When these two vectors act on this body at angle of 0 degree, or when they are parallel, you get the maximum effect. Okay, let's put magnitude to what we're saying. Let's say A is 5 Newton and B is also 5 Newton. So we'll get a resultant effect, 10 Newton. 10 Newton. And I bet you no other angle can give you 10 Newton. Every other angle will give you something less than 10. So that implies to get the maximum resultant vector or maximum resultant force, the vectors must have no angle between them or 0 degree. Okay, then let's justify that using angle 90 degrees. Okay, so when they are parallel, no angle between them will just add up because they're going in the same direction. 5 plus 5 will give us what? 10 Newton. That simply implies when one person of 5 Newton is pushing a car, let's take this to be a car, and another person of 5 Newton pushing a car, both persons will make total push of 10 Newton on the car. That's the maximum resultant force for these two individual forces. Then let's see what happens when one person is pushing at this angle, another person at that angle. In between the two vectors will have 90 degrees. Okay, let's know whether we'll get something bigger than 10 or something less than 10. So we can justify the angle argument. So to get the resultant vector here, we're not adding. Because they form the adjacent sides of a triangle, use Pythagoras theorem. So to get the resultant vector or resultant force, we'll be using Pythagoras theorem, which says, okay, we'll take it from here. R squared is equal to, here is 5, there is 5. Let's still maintain the same magnitude. 5 Newton, 5 Newton. 5 square plus 5 square. Okay. R square is equal to 5 square will give me 25. 25. R square. 25 plus 25 will be giving me 50. Then square root both sides. R is equal to square root of 50. Therefore, R 5 sub 2. In decimal, I'll be having R is equal to 7.07 Newton. So you can see that we're having a smaller magnitude compared to 10 Newton that we had here. That implies to get the maximum resultant vector or the maximum resultant force, the angle, the preferred angle is 0 degrees, so that we can just add up the vectors. Yeah, thank you. Stay tuned as we go on.